And that's all the examples I've got for you in this one, but we are going to finish with an exam style question. And unfortunately, it is a tricky one, okay? This is one we haven't really covered, but I'll give you a few clues of how to do it. We've got a region R which is bounded by two curves, A and B. I've given you the equation of each of the curves. Here's the equation for curve A. Okay, so this one is y is x squared minus 6x plus 11. And curve B is y is 6x minus x squared minus 5. I want the area in between those two curves. That's pretty tricky, okay? I'll give you some hints. The first thing is I've given you the coordinates of where the curves cross each other. Could work that out by solving simultaneous equations, but I've been nice and just given them to you. So if we drew some lines down, that's at x equals 2, that's at x equals 4. How do we find the area in between those two curves? Have a think about how we can use each area separately. Underneath curve A, if we integrated, we'd get this area, okay? Underneath curve B, sorry, apologies, the area I've just drawn is underneath curve A. Now underneath curve B, we'd get all the area I've just drawn plus R, wouldn't we? Okay. Have a think about how we can combine those two to get the area R. So the area under B gives us everything. The area under A just gives me the shaded region I've got here. Okay. So if we do the area under B minus the area under A, that's going to give us the region R. Okay, so again, we're combining different shapes. Don't worry if you didn't follow that. It's quite complicated, and I'm going to do the worked example in a second. But for the sake of having a go at doing something, see if you can find the area under A and the area under B. Think about what the limits are. Remember, we're between 2 and 4. So they're going to be the limits of our integration. So find the area under A and find the area under B. If you can figure out how to combine them to work out the area of R, then very well done, because this is an extremely tricky example, and it is very much exam standard. Okay, so spend a few minutes even having a look at this this example, and we'll go over the worked answer in a few seconds. Okay, hopefully you've had a chance to have a quick look at that question, have a think about how you do it. Hopefully you've paused the video and have a bit of a look at it. So I'll go over the worked answers now. This is a very tricky one, so don't worry if you got stuck. Okay, so I've put all the information we need in this top corner here. We've got the equation of curve A, equation of curve B, and the two intersection points. Okay, so we'll draw those lines back on for x is 2 and x is 4. There are limits. Right, now to get the region R, how are we going to get that? Right, well the area under A is this shaded region here, isn't it? Between 2 and 4. Now the area under B is all the area I just shaded plus the region R. Okay, so hopefully you can see that to find R, what I'm going to do is the area under B, which gives me everything, minus the area under A, which is the region we don't want, that bottom shaded region. Okay, that's how we're going to find the region R. So, okay, let's start with the area under B then and see if we can figure that one out. Now the area under B, to do that, I'm going to integrate between my two limits, which are x is 2 and x is 4. And I'm going to integrate the equation of curve B, which is y is 6x minus x squared minus 5 dx. Okay, so got my limits, got what I'm integrating, so I can go with this one now. First step's to integrate. So 6x becomes 3x squared, x squared becomes x cubed over 3, and if we're integrating a constant, we just put x on the end, and I'm going between the limits of 4 and 2. Okay, now I can substitute in my two limits. So let's do the upper limit first. So we always do the upper limit minus the lower limit, remember? So we've got 3 lots of 4 squared minus 4 cubed over 3 minus 5 into 4. Okay, so everywhere I've just substituted in the upper limit here. And I'm going to subtract off the lower limit, so I'm going to substitute the 2 in. So 3 lots of 2 squared minus 2 cubed over 3 minus 5 times 2. Sorry, this is meant to be a cubed here. Okay, and that's my lower limit. And I do my upper limit minus my lower limit. So you could just put all this in the calculator. I'm going to work out each term just to make sure we don't go wrong. So 3 times 4 squared is 16 times 3, which is 48, minus 64 over 3 minus 20. And I'm going to take away 2 squared is 4, times 3 is 12, minus 8 over 3 minus 10. So at this point you can just stick all this in the calculator. I'll do the upper limit first. So I'm going to put all the stuff for the upper limit into the calculator, and that gives me 20 over 3. And I'm going to subtract off the lower limit. So all I do is stick all that bit in the calculator, which gives me minus 2/3. Okay, so minus 2/3 here. 2 minuses make a positive, so I get 22 over 3 for this area. Okay, it's about 7 or 7 1/3. Okay, that gives me the area underneath B. Now I need the area underneath A, so I'm going to come over here and do the area under A. To do that one, I've got the same limits because we're going between 2 and 4 again. Yeah, still the same x limits. But this time I'm going to integrate the area for A, so that's x squared minus 6x plus 11 dx. Okay, so if I integrate it, x squared becomes x cubed over 3, 6x becomes minus 3x squared, and then plus 11x, and the limits of 4 and 2 are still there. Now I substitute in my limits, so instead of x cubed over 3, for the upper limit I'm going to get 4 cubed over 3, minus 3 lots of 4 squared, plus 11 times 4, so that's all the upper limit done here, and subtract off the lower limit, which is 2 cubed over 3, minus 3 times 2 squared, plus 11 times 2. There's the lower limit, and then if I put each term in, work out each term, and then we'll put it all in the calculator. So that's minus 48 plus 44. Subtract off 8 over 3 minus 12 plus 22. I'll work out each bit, so I'll start with the upper limit and put 64 over 3 minus 48 plus 44 in. That gives me 52 over 3. And for the lower limit, we get 8/3 minus 12 plus 22, which gives us 38 over 3. Do the subtraction, and that gives me 14/3. Now we said R is the area under B, so the area under B minus the area under A. So that's what we do. Area under B was 22 over 3. Area under B is 14 over 3. Sorry, area under A even is 14 over 3, which gives me a final answer, an area of 8/3. Okay, so the region R has an area of 8/3. So really tricky example, that one. Well done if you followed it. Make sure you're happy with doing the definite integration first, and then have a look at some more of these complex examples where we have to work out several areas and do subtractions or additions. And that's everything I've got for you on integration. Next time we're going to move on to vectors, which is a bit of a mechanics type topic really. It's good practice for the applied maths paper you have to do on mechanics and statistics where vectors come up again. So definite integration is a very hard topic, so have a look at the website at Solve4x. There's loads of stuff there to help you practice. Some quiz questions to have a go at, loads of problem questions, and more worked answers from me so you can see how to work out the really complicated questions. There's also a summary of everything we've been over today just on one side of A4, so you can kind of summarize everything from a half-hour lesson. So thank you very much for watching this video, and I'll see you again next time.